Hello and welcome to our channel again. So here I am Suraj again with a new video on a mathematical physics which is going to be on the partial differentiation. So in our previous videos we have discussed about the Fourier series. Also we have discussed about the vector operators. It means divergence, curl and etc. So now we are going to start another mathematical parts which is very important in everywhere in physics, which is a partial differentiation. So now let's start our lecture on the partial differentiation. Okay, so here our topic partial differentiation. So I am assuming that you know the basics of differentiation, that what exactly the differentiation is. Okay, so I am here now going to discuss the advanced version of the differentiation. So this is a partial differentiation, not the normal differentiation that you do in the class 11th and the 12th. So the prerequisites to this particular lecture on the partial differentiation is the basics about the differentiation. So might in the another video I will discuss about the basics of the differentiation, but for now our topic will be the partial differentiation. So what exactly this particular partial differentiation is? Now let's start talking. So you know what's the function is? Yeah, we know the function. Function is any type, like when we write f of x, it is a function. It means any dynamical variables that is dependent upon x. Maybe we can write this that y is equals to x squared. Okay, so y is equals to x squared. It means what we are now saying is that f of x is equals to the x square. It means y is dependent upon the value of this particular x, so the y becomes the functions of the x. So that's the meaning of the differentiation of that particular. Or now we'll discuss about the so here we can define the function. So this is the basics definition of what the function exactly is. Now moving toward the differentiation, partial differentiation. You may have read about the normal derivatives. What's the normal derivative? Normal derivative means d by dx. These are the normal derivatives. For example, d by dx of the x squared. Yeah, this is a very simple question. So this becomes 2x. Okay. So this d by dx is only applicable if there is only one function. Like we can say that this particular f of x is only dependent upon the x square, so it is a single variable. So this is a single variable functions. It means it is not dependent upon the another variables, like may say y, z, or whatever the variable is. So in this case, when there is only one variable x square, we uses the normal differentiation you have studied in the class 11th and 12th. But when there is a function which is dependent upon x and y both, let's assume that I'm assuming f of x plus y, f of x y. So what this means, f of x y, it means the function that I'm now gonna write is a particular dependent upon x and y, which is I can write x y squared. Now this particular thing f of x y may take its z is now a function of xy squared. It means it's now dependent on the values of xy squared. So in this case you can't apply this particular d by dx because there is two variables x and y. So when there is more than one variable, then the differentiation tool that we use is known as the partial differentiation. It means if someone asks you to differentiate this particular quantity xy square, you will give the symbol of this, which is a sign of the partial derivative of this function with respect to the x. So this is the sign of that particular thing, and this means that there is a two functions x and y, but you have to only operate this particular del by del x on x, and that will give us y squared. So now you understand what the importance of the partial differentiation is. So partial differentiation generally represents, or generally you can say acquire, when you have defined more than one functions. Its uses are applicable when there are more than one functions. You can't apply this particular del by del x for x square. For x square, there is a normal derivative d by dx. But for more than one function uses a partial differentiation. So that's the meaning of the partial differentiation. So we have tell about that if there is a function, if there is any type of function which is dependent upon more than one value, like you can say that here I defined y is equals to x squared. It means y is only dependent upon x. But here you can see that z is equals to xy squared. It means that it's now dependent upon both x and y squared. So if anyone asks you to just differentiate this function, you will not apply this particular d by dx. You will apply this particular del by del x. And how you can do this, we are going to talk later, that how you do this particular things, that how the del by del x of xy square become x, why it's not operate on y. So we are going to discuss in the later video. But for now, you understand that why partial derivatives uses. Its uses is that when we define more than one functions. Okay, so this is basically the meanings of the partial differentiation. So now that's the basic definition. So now let's some examples on basis of this partial differentiation. Some examples I'm saying is that let's say x square y cube. Okay, so this is a function which is dependent upon x and y. Okay, so this is two variable. So whenever you ask to differentiate this function, you will apply del by del x of x square y cube. Okay, so what's the particular value of this? So the thing is that here I am saying is that take the partial derivative of x square y cube with respect to x. So for example, when we say that find the d by dx of x square, find the d by dx of s square, what we will do, we operate this particular operator d by dx in the x square, and what we get is that by a simple power formula in the differentiation, which gives it is equals to the 2x. But now here is a two function. So if someone asks you to do the differentiation with respect to x, only, what you will do is that you will keep y cube constant. It means you just put out y cube after this particular operation, just out of this particular operation, and operate del by del x only to this particular x square, and I think this will become 2y cube x. So this is a partial differentiation of x square y cube. Y cube just out of this particular expression, because for del by del x, y cube is a constant. So y cube is a constant. Okay. So you have heard of the rule in the differentiation that when you have to differentiate 2x, what you will do? You just put 2 out of this equation, because 2 is a constant. 2 is a constant, and just differentiate the only x here, which will give you 2. Okay, so just like this here, y cube is a constant with respect to the del by del x, and we just put out of the y cube from this particular expression, and we get this particular partial derivative of x square y cube. But when we do the partial derivative of this particular function with respect to y, what will become? When we partial with respect to y, so now x square is a constant for del by del y. For del by del y, this particular x square is now constant, and x square just put out of this from the equation, sorry, from this operational formula, and we apply only del by del to the y cube, partial derivative of the y cube only, because it treats x squared as a constant, and what we will get is 3x square y square. So this is the particular thing of the partial derivative, that how you defines this particular partial derivative. So this is a basic meaning of partial derivatives. This notations came when we define more than one variables, and when you have to differentiate more than one variables, so that we can understood our concept better. That's why we uses this particular partial derivatives. Now moving towards some more interesting topics in the mm, partial differentiation, which is a total differential or a total derivative. Okay, what's this particular thing is? So our topic now is going to be on the total differential. Total differential. So what this particular differential is? Now we will define this particular differential. Suppose that you assume any function which is dependent upon x and y both. Suppose that. Okay, so this is a function which is dependent upon x and y both. So if I do a very small change in x, infinitely small change in x, and infinitely small change in y, how we can define this? So you may have heard in the differentiation that differentiation is nothing. Differentiation is just finding the slopes of the curve, or in a better language, differentiation is just finding out the rate of change of the particular quantity for an infinitely small period of that particular time, distance, or whatever your thing is. Okay, so here if I do a very small change in x and very small change in y, then there is also a very small change in df. So you may have remembered that small change in mathematics and physics is represented by del df. In this function, the small change in distance is dx. So this is a way how you can describe the small change where the x tends to the 0, limits x tends to the 0. So if there is a small change in x, small change in y both, there is also a very small change in the whole function f of x and y, and we write this particular whole function as dfxy. dfxy. This is known as differential. The infinitely small change in the function is what known as the differential, and this is small change. How we can write this a small change? So this small change can be written as like this, which I'm going to, it's a very interesting thing. Okay, I will explain this. Del f upon del x dx plus del f upon del y dy. Oh, what this thing is? So the thing is that when the differential, when we change a very small change in x and very small change in y, there is also a very small change in this whole particular functions, which is known as dfxy, and this is known as the differential. And this is small change, how we can represent this small change in a mathematical terms, how we can explain this particular things in a mathematical terms? So the small change, this df, can be represented as the partial derivative of this particular function with respect to x dx plus the partial derivative of the function with respect to y into dy. Oh, that's great. We can define that particular small change in function in its partial derivative with respect to x and in partial derivative with respect to y, and this is a very powerful property of this, but this is known as total differential. Representing this particular expression, this particular differential, in the form of its gradient. Its gradient is a very hard term, so I will tell you, in the form of this rate of change of this particular in x and y both axes, it was known as the total differential. So this is a very powerful property, the partial differentiation, which can use to express various types of the phenomena. Okay, I will explain one more thing. Okay, I will explain from the beginning that what I have discussed. We discussed what function is. Functions means dependent. Y is a function of x means y is dependent upon the x. If I put the value of here x1, y is 1, it's all dependent upon the x. And when anyone tells you to find out the derivative of this x squared, the simple formula you can do this 2x. So I'm going to write here the formula. Okay, so I think I have to write the formula that whenever there is an x to the power n and someone asks you to differentiate this particular x to the power n with respect to the x, what's the particular differentiation of this particular term? So this differentiation is nx and n minus 1. So you can also prove this particular phenomena, but we are not going to prove here. Okay, so we have defined this particular thing. But what happens when we deals with more than one variables, which I have written here xy square. So in this case, we take the partial derivative of this particular function. When there are more than two functions, we define the partial derivative, and now you can see here that how we do the partial derivative. We treat y cube constant when we are doing partial derivative with respect to x. We keep x square constant when we do the partial derivative with respect to y. So this is how we can do the partial differentiation of the two variables. Partial differentiation of the two variables, and this is how we can do here. If this particular operator del by del y treats x squared as a constant and this particular del by del x treat y cube as a constant, put this out, do the differentiation. Okay, so this is a notations of the differentiation when we are differentiating more than two variables, sorry, more than one variables. So that's okay. So this is the partial differentiation. Now what's the total differential is? So total differential may be defined as, suppose that there is a function f of x and f of y. It means it is dependent upon x and y also, and you made a very small change in x and very small change in y. So if you change x and y very small, this is infinitely small change, very infinitely small change. Okay, we take this as a limit to 0. Very small change will do, very small change. So f of xy generally it will also change. If these two functions change and this is dependent upon this function, then this particular functions may also change, but in a very small amount. And this is what known as the total differential, that defining the very small change in this particular function df of xy in the form of this particular expression. This particular expression के फॉर्म में अगर हम इस पर्टिकुलर डिफरेंशियल को रखेंगे तो दैट्स नोन एज द टोटल डिफरेंशियल. इसका मीनिंग क्या है? इसका मीनिंग ये है कि ये जो f of x y है, चलो मैं लेट कर लेता हूँ, लेट f of x y any functions, let f of x y any function, let's say it is x cube y, sorry here x cube y. So this I will assume it. Okay, so if I made very small change in x and very small change in y, then this particular df is defined as, when you do this particular expression differentiation with respect to x into dx plus del upon del y, it means differentiating again this function with respect to y into dy. So this is how we can define the very infinitely small change in the whole function with respect to the partial derivative in x and y. So this is a video of mine where I have discussed about the total differential, what is the partial differentiation, and how we can do the partial differentiation. So I will try to make a video on the basics of the differentiation so that you can understand this lecture. So in the next video and or in the upcoming videos, I will discuss about the exact and the inexact differentials, because this is very important in the physics phenomena also. So we are studying the mathematical physics obviously, so we have to discuss those things. So thank you for watching my video on this particular partial differentiation topic, and hope you like the video.